Hi everyone, it's Mrs. H. This is part 2. So we're going to just see some different scenarios for writing quadratic equations. And you can see on the left here, I already solved. I solved by factoring. What we're going to do for our first part today here is we're going to take our roots, we're going to take our answers when we solve, and we're going to work backwards to figure out the equation. So we could do that here with these two roots. I have 4 and -1. Now, if I were doing this, I would say to myself, in order to get 4, well, I know it's a quadratic for now, so I have my two binomials. In order to get 4 as one of my answers, I would have to set this binomial equal to 0, so I would have to have x minus 4. For my other binomial, to get -1 as an answer, it would have to be x plus 1. And then I could multiply these together. When I FOILed them out and combined like terms, I would get this as my equation. Notice that this is slightly different than what we did over on the side in orange. But what I did over on the side here, well, I factored out a 2 just because that's kind of habit. But because this equals 0, I could have absolutely just divided everything in this original equation by 2, and I would have gotten back this x squared minus 3x minus 4. All right, so we do get back an equivalent equation, even if it's ever so slightly different. All right, now paying attention to where these numbers both came from. This -3, well, that came from outside, inside when we were FOILing. And this -4, that came from last times last. I could also show that x squared is being from first times first, but for now we're not going to worry about that. What happened is in pink here, I had -4x plus 1x. So I added -4 and 1, and I got -3. Hey, where have we seen these numbers before? They were our roots. In blue, how did I get -4? I multiplied -4 times 1. Again, hey, where did I get those numbers from? They look almost exactly like our roots. So what we're going to do here is we're going to just notice those patterns that happen. The only thing that I've got to be careful of here is that my roots were +4 and -1. But when I did this work over here, I had -4 and a +1. So we have just one little tiny thing we've got to switch. What happened in our equation? Well, if I look at this equation here, I had x squared minus, well, I had -4 plus 1, but we're talking about the roots. So if I were to add 4 and 1, I would get a +3. So let's do the opposite. So I'm going to add my two roots together. I'm going to multiply them by x, but then I'm going to take the opposite sign. I'm going to show that in my equation by this minus. With my multiplying here, it doesn't matter because all I did in my roots is I took that negative and I flip-flopped it over to the 1 instead. And so this one, it doesn't actually matter if my roots had the negative with it to start with or not, since you negate both of them. All right, so writing this a little bit differently, what happened is I have my equation. Oh, and sorry, I lost this equals 0. In my original problem, what happened here is we had this 2. So let me add that in because we could multiply everything in this equation by 2. Sorry for all the changing colors. Let me fill in what I know first. And then I'll go ahead and I'll fill in my roots added together and my roots multiplied. All right, or, oh, and I guess I should close my brackets here. I could write this again a little bit differently as a, oh, I did not mean to write 2 here. I meant to write a. I could write a times, and then inside what happens is I have my x squared, I have my minus something x, I have my plus something. This all equals 0. What is another way to describe what I did in pink here. Well, that was the sum of my roots. And in blue, what was that? That was the product of my roots. All right. So what we're doing is called the sum and product rules of finding our quadratics. Let's do that with 2 examples. All right, example number 1 here. I have 2 roots. They are fractions. That's okay. I'm going to add these 2 together, and I'm going to multiply them together, and I'm going to get the sum and product first. I'm going to leave, most of this to you. When I add these together, I already have a common denominator, so I get -2 as my sum. When I multiply, I'm just going to multiply top times top and bottom times bottom, and so there we go. We get our product. Now I'm going to go plug those in, and I'm going to write my equation. We had the starting equation here. I'm going to write down x squared. I want minus -2, so that's going to be plus 2x, and plus a -5/4. Well, I'll just write -5/4 equals 0. That was my original, but one of the things that I did not yet mention is that these questions are not just going to say find a quadratic equation. They're going to say find a quadratic equation with integers, or I think the worksheet says integral roots. So no fractions. We are not allowed to have -5/4. Well, we can easily take care of that because I can just multiply everything in this equation by 4. I get 4x squared. I'm going to distribute, so I get plus 8x. I get -5 equals 0. There is our nice looking final equation. We can do this with all sorts of roots. So here, I'm going to find my sum, and I'm going to find my product. When I add, the i's just go away. Notice that this original problem gives you the question like this. You might see it as 2 plus or minus I over 3. 100%, I would split it up into the 2 cases. Because then when I'm doing product, I'll just throw parentheses around, and I'm going to FOIL. Well, I'm going to cheat a little bit and just do it out myself. Hopefully we all feel okay with this. At that point, I get 5/9. I'm going to go and plug in. That means I'm going to have x squared minus 4/3 x plus 5/9. Because the way we write these, we set them equal to 0. This is going to allow me to get rid of my fractions. I have a denominator of 3 and I have a denominator of 9. So I'm going to multiply everything in this equation by 9. And I get 9x squared. One of my 3's cancels with that 9. So I get minus 12x. And then my 9 cancels, so I get plus 5. That is the answer that I want. All right, next, we're going to kind of take a deeper look at this so that we can do a problem that's a little bit more complex. Notice that we have this equation as our standard form equation. What is not taken into account here is that we don't start with our ax squared. We've been starting with our just x squared. And so what I'm going to do here is I'm going to factor out an a. And when I factor out an a to have my starting equation, I'm going to have b over ax, and I'm going to have c over a. And so when I look at my sum of my roots and my product of my roots, I now have another way I could write those. I could write the sum as the opposite of my middle term, which is negative b over a. And my product is my c over a. We're going to use this to answer question number 6. We're going to find a quadratic function in standard form such that the maximum value is 4 and the graph has x-intercepts at -5 and 1. First, we've talked a lot about kind of these graphs in general, and so I do want you to kind of think about what this looks like. X-intercepts at -5 and -1 means I'm going to be here at -1. I'm going to be over here at -5. I could find my axis of symmetry. My axis of symmetry is going to be right in the middle here. So what's in the middle of -5 and -1? Well, it's at -3. So you do know some other things just really quickly on this graph. The other thing that this tells us is a maximum value is 4. I now know exactly where that vertex is because that vertex is on my axis of symmetry and it's up here at 4. That's going to be -3, 4 is my ordered pair. Hopefully, having these 3 points, you see that maximum value is also telling me that this graph is concave down. It opens down. This again is another self-check that I can take when I have an answer because I should have an A value that is negative. All right, let's do the algebra now. I'm going to find, well, I know both of my roots, so I'm going to find my sum of my roots, and I'm going to find my product of my roots. I do like to write these down, even when it's easy numbers like this. All right, now, that means my function. Well, I've got to use my function notation because they told me to here. But when I write it down the first time, I'm going to write it with that A factored out. This is going to give me x squared minus -6x, which is going to give me +6. And then I'm going to have +5. Now, what am I trying to figure out? I'm trying to figure out this A value. I want to know what A is so that I can go back and write down this whole equation. I do know an ordered pair because remember, I knew this -3, 4. So I'm going to plug in 4 for y, or f of x, and I'm going to plug in -3 for x. -3 squared is going to be 9. Oh, I'm going to have to really make sure that these look different because my a's and 9's look the same. I'm going to have 6 times -3. It's going to be -18, and then I have +5. That's going to give me 4 equals A times -4. When I divide, I get that A equals -1. Taking that step back, my self-check does in fact work because opening down means that I have a negative A value. We're not done. We want to plug in that A value and then we want to distribute it to get our nice final quadratic function. F of x is equal to -x squared. I distribute my -1 to get -6x. I distribute to get -5, and there we go. This is something that you could check. We know how to graph this. Go through your steps. Make sure that this is, in fact, your vertex at -3, 4. Solve this. You could factor it to make sure your two x-intercepts were -5 and -1. There's a lot of kind of self-checks that you can do for these types of problems. All right, there's one more question I think that I circled. Oh, I had 2 more circled. Let's do these where we're finding k. I want to find k so that whatever I'm told is true. So here's my equation, and one of my roots is 3 plus root 2. What does this mean? A root is when I set this equal to 0 and I get a true answer. I do not want to go through all my steps of plugging in my 3 plus root 2 for x. That's way too much work. We're going to use our sum and product instead. My sum of my 2 roots is going to give me this -4. That's where I'm going to start. If I have 3 plus root 2 plus my other root, I'll just call it r, I'm going to get the opposite of -4, so I'm going to get 4. I can solve this. I can subtract my 3 over. I can subtract my root 2 over. Now I know both of my roots. I'll call this one root 1, this one root 2. All right, now that we know those two roots, what I can do is I can say, oh, wait, when I multiply those roots, I get k. So 3 plus root 2 times 1 minus root 2. I'm going to cheat a little bit because I have the answer in front of me. I'm going to FOIL it out and I'm going to simplify. And I get 1 minus 2 root 2. That is my k value for question number 8. Question number 9. We are going to use something here that we know. First of all, I do know my product, but oh wait, I don't actually know my product yet, because if I want to use that, I've got to divide everything because I want an x squared. So if I wanted to do that, I could do x squared plus k over 4x plus 25 over 4. If I divide out my 0, I still just get 0, so that's fine. Now I can do my sum and product. When I add my two together, I'm going to get k over 4. I'm going to get the opposite of k over 4. When I multiply them, I'm going to get 25 fourths. I do know one root, but you actually know the other root because, at least for now, our roots are going to be conjugates. So I'm going to have 3 halves minus 2i. We could confirm by multiplying these that the product was in fact 25 fourths. I'm going to tell you that it is. So all we need to do is we need to add them together in order to get our sum. 3 halves plus 2i plus 3 halves minus 2i should be equal to the opposite of k over 4. Oh, so nice. My eyes are gone. I already have common denominators, so 6 fourths equals negative k fourths. Immediately, you know, oh wait, shoot. Oh, sorry, 6 halves. Basic mistake, that was ridiculous. Ignore that I did that. I'm going to cross my 4 up. I have 4 times 6 over 2. 2 goes into 2 once, 2 goes into 4 twice. So I get negative k is equal to 12, which means that k is equal to negative 12. All right, so this is kind of scenario number 2. There, again, are some more problems on here that you could do, but I'm going to leave them for you to try. When I do eventually post these notes, I will include them all done out.